Hey, so in this one, we are preparing the movement for characters and we are starting with a chicken. It's kind of funny because it's kind of the logo of my game for now. So yeah, we're starting to make the movement for the chicken. Yeah, after that we can start to do the intelligence for our characters, but yeah. So hope you enjoy, it's quite a long video, so... So we did the tile properties and the stat last time, but for now we have no way of representing a character. So let's work on this. And we did human stat, right? But actually I think I'm gonna rename this base stats, because we are probably are going to use this for animals, and just add the skill for the humans, right? Oops, sorry. So actually, let's copy everything. Let's rename this base stats, right? And so maybe we don't want this for the animals. We only want. So let's mark this virtual, right? Yeah. Mark all of this virtual. Let's register this as base stats. And in human stats, right, we are going to base stats. Let's call base here, right? Let's remove all of this and let's just add the inventory size. Okay. So my idea for this episode is to make, for this video, is to make, so, sorry, I'm doing other stuff on other project. But yeah, basically what I want to do is I want to be able to see characters, right? And maybe work off the movement or something like this, and basically prepare everything for the jobs, right? So private override, right? Oh yeah. Yes. Right. Yeah. Okay. Let's move the inventory size in human. We already did that. So road vitals we don't need to override. Right. And yeah. So yeah, actually I should do best attribute. Yeah. And we will add the skill eventually and other stuff here, but for now that is going to be enough. And maybe we can work on an animal actually, instead of working on a human. Because the job system is going to be really simple for the animals for the start. Basically we will have spawners and they need to eat and sleep, right? So maybe we can work on this. So let's make a base class called character. Well, actually, do I want this virtual? Maybe. Okay. Virtual. What's your problem? Valid. Oh, that's stupid, sorry. Yeah. Well, we want some base stats, right? And this is not virtual, so we can just do and in the constructor. Actually, we need this with vector to position, right? And let's do this dot stat again, new base stats, right? Maybe a creator should have a definition for the graphics. Yeah. So maybe we want a definition, right? But not a tailable def, another type of definition. So let's check our def. Tailable def is just. So let's add a new one and call this, let's copy this actually. And let's call this animal def, for example. And we don't want a layer, maybe we want a layer, I'm not sure. Yeah. So we don't want actors. Right. And let's call this animal def. Right. So let's add a definition, I suppose. Well, yeah, sure, but we should have something like living def, right? And animal def is just right, something like this, right? And so I will run this file later, but no. So yeah. Yeah. Right. And maybe we want base graphics, but we don't want this to be mandatory because, for example, our elements are going to be composed of multiple layers, one for the head, one for the body, one for the hair, one for the clothes. So we want this to be optional. So what we could do is right, and let's do something like how do we do this in Tailable, right? Maybe we don't. Well, let's do this in animal because we don't want this to. Yeah. Okay. But this is a structure, right? No, this is a class, so this can be new. Alright, so it's okay, I guess. So let's do if this dev.graphics graphics graphics get this get dev, right? then we need something like movement or character movement, right? So let's make a new file again, and I will call this character movement. I don't know. Well, let's call this yeah, character movement, sure. About this. So alright, and for now we'll just have a position. And the character actually, well, yeah. Do we want to reference to our character here? Not sure actually. I'm not sure we need to. Let's not do add one for now, and I'll show you later. Alright, and so let's do public character movement. Right, and maybe we want a getter for the position, right? Like something auto on this movement position, right? And so let's instantiate the movement. So this should be our base. Now we obviously will need an update function. But yeah, I think that's it for now. What else do we need in well, we need something for the AI, but not right now. So let's just do an animal class, right? Class animal base character, right? And let's do public animal So now we can instantiate an animal, right? And for the graphics, I'm not sure. There is two options. We could do a renderer for this, right? Or just do a graphics.formation.set, or we could just use a mono behavior, right? So yeah, I'm gonna think about this and we'll see later, right? Enjoy, see you next time, bye bye. So, hey, so last time we did this, we set the base for a character, right? And so in this video, it would be cool to see something moving. And for this, I made yeah, we will use the logo of my channel, kind of, with a chicken, right? So I need to find my chicken, right? So where is this fucking desktop? Yeah, is it here? Right. Go to Firewall. Sorry, share this on screen. Firewall assets, file, resources, textures, add animals. Let's add a chicken from. Let's call this chicken from just to because we'll need a back view and a side view. Now this is gonna be fine. It's so beautiful. Like this is my best artwork ever. When you look him in the eyes, like if you start to look too long, you will start to ask yourself, why do you exist? It's kind of creepy. Well, anyway, moving on. We need to show the chicken, right? So, well, it's just one mesh, right? So we could do something like public virtual void under or something like this. And have a private mesh, right? And if this dot mesh equal null, this dot mesh equals mesh pool dot get mesh, right? This dot dev dot graphics dot right. Yeah. We also need to check if this dot graphics equal null. Let's return, right? We don't want to do this if we don't have graphics. So if we don't have a mesh, we create one. And yeah, if this is the case, we just need to draw the mesh as the correct position. And for now, this is going to be graphics dot mesh. This dot mesh. Okay, I don't remember the definition for this, but we have this in our renderer, I guess. Yeah. Let's copy this. This dot mesh, this dot position for now. Graphic instance. Dot material, right? And in right. So we need two updates actually. We need a graphic update and the update, right? On there, let's call this. Well, actually, we could just run this one. Right. So why is it not working? Right. Yeah. Can we convert this to vector tree? Not really. Actually, in movement, we will have the vector tree, the position in a vector tree. But for now, let's do something really shitty and let's do this in here. So this dot position dot x, this dot position dot y, and the layer that will be we'll use count actually, layer dot count, right? Because we want our characters to be on top of everything. So this should work. Yeah, this is get plain mesh. So this should work, right? So now when we spawn a character, right? Now we should add in map. we should do we should add here. And we just do we'll just have a private list of character or public actually. Yeah, list of characters for our map. Right. And I don't know if this is going to stay here, but for now it's fine. Alright, and let's add the character, right? So this dot characters dot add. Well, yeah, sure. Right. And yeah, do we have an update function in the map? Really? Hmm. This is kind of shitty. I don't want. I'm not sure I want this to be in map. Maybe I want a characters class, right? But let's do this like this for now, right? So what do I want to do? And yeah, in game manager, it should be in game manager. Here we want on update. Well, I should have called this draw characters then, right? And let's spawn a chicken, right? Oh yeah, we don't have a chicken yet. Chicken. Let's copy this. To another add the animal. Sorry, add animal. Feeling that right. Right. Let's put this chicken. Chicken font. Let's remove the color. Remove the layer. Let's solve this. Let's solve this animal. Right. Let's define an array for list of animal definition. Okay, and animals from code. Loki. it. Right. Why is it like... Oh, I see. Okay. Deaths, loader. So let's check if I have some errors. Okay, nothing. Oh, good. So let's spawn the chicken, right? Game manager. Right, so we can command this right now. Let's do this.num.spawn character, new animal. Actually, I don't need the position here. New animal, new vector 3, 2. Let's do cancel 15, 15. The animals, chicken. Right. So yeah, we should see a chicken right now. Maybe. I don't know, I made a lot of modification. Yeah! There is a chicken. Right. So he's not moving or anything, but he's down, he's using our definition system, and added with the spawn function in the map, right? So that's pretty cool. So maybe we want to make him move now, but for this we need something called, we need some task, right? And I don't know if I will make this task in this video, but we can start. We could start thinking about the movement, right? Because for now our character movement is empty. The movement, basically we will need multiple things, but we'll need a destination, right? And we need maybe a speed, right? But the speed is going to be given by the stats, so maybe we need a reference to our character after all, right? Yeah. So no speed. Maybe we'd want to know which way the character is facing. So we have direction, right? So we can just use file that helpers. Let's call this looking at, right? So this way we can know where the chicken is looking. We need some private too, and this is just the way I do the movement in 2D games, but you don't need to do this like this. Just, I don't remember, I saw this in an article a long time ago, in a tutorial or something like this, and I like this way, so now I always... But, so let's call this movement person, basically, right? Let's also add the bool as destination, right? Just to optimize a little bit. And we'll also need private vector print next position, and this will use a star later, but we need to know the next position we are moving towards to. And maybe we need a queue, like a star will give us a queue, right? So a queue of vector twins, right? And we call this path. Yeah, I'm stupid. This is all private, right? Yeah, and basically that's it. Maybe we need a callback when we change directions or something like this, but yeah. Oh, and we need a vector tree. Basically, we'll need a vector tree to represent the real position. And the way I'm going to do this is we'll call this visual position, right? And we'll do a getter, and we'll do the math here, right? So this will return a new vector tree where x is a layer of the position on x, the next position dot x, and the movement percent, right? Same for y, right? And after that, we just need to calculate the movement percent. Make object move and we fetch it right? And this is just layer it is dot 8 layer dot count. Right, so this is our visual position, right? But in reality we are in a tile. This is just visual. We're never between tiles, right? We are on one or another, and we have a movement percent, and this represents our visual position. But our character is always in a tile. So for when we initialize this, we need to do this the destination equal position, and this dot as destination equal false, right? And this dot next position equal position. Basically, this is and actually I will make a private void reset movement, right? And I will also do this dot movement percent equals 0, right? And we initialize, we reset the movement. Obviously we need a function to know the lookat, so I will not code this right now, but we'll just do the method to not forget, right? In this actually I should also reset the path, right? And obviously we need a move function, right? And for the move function, we'll need a task, right? With a target, and we are going to move towards the target, right? But basically, for now, we can just do destination, alright? And so if we already are moving, this is incorrect, right? We are not supposed to call a move while we are already moving. So only if this dot as destination equal false, here we get the path, get path for new destination, right? So we do that, right? And initialize the path and everything, right? If it's possible. If it's not, we just reset. And we need to check are we on our final destination, right? So if this dot destination equal this dot position, we need to reset the movement for sure, right? And return and get out of this, and after this we need to also do if this is the destination and next position, right? And if this is true, we need to do this dot next position equal this dot path dot dq, right? When we reach the next, here we'll take the we'll set up this dot path and set next position to the first value in the queue, right? So if we reach, we take the second and the third and the third star, right? And here we should update the lookout also, right? When we change destination. And then once we did all this, we just need to update the percent, right? So we need to know the distance, right? So the distance is right. We calculate the distance like this. Matf.po, and we need to convert this shit to float. Well, actually, this will be always one, right? Well, not always, but we could pre-calculate this. Basically, it's 1 or 1.57, I think, because it's diagonal or it's not, right? Yeah. So we'll do this for now, but we'll change this eventually, because actually we try it now. Yeah, why not? Right at 1.4. So yeah. So let's do right. Float distance equal 1f, right? And if matf.address. So here I need to calculate the to know if it's a diagonal, right? I do this dot position dot x dot this dot next position dot x equal 1, and then same shit for y, right? So if we have 1 and 1, that means that's a diagonal, right? And we can just do distance equal 1. No. Yeah, this is faster, obviously. Because we update this each time we cross a tile, right? So we need to know the distance we travel this frame. For now, let's add something called speed, because and then we will use the character stat, but for now let's do, I don't know, I need to test this shit, but yeah. So to know the distance we travel this time, distance traveled, or distance this frame, or call this whatever you want. Basically, we should take the grand pass penalty here, but for now let's just do this at speed, right? But Here, use the path cost of the tile vector. Actually, oh no, because it's 0 for now. Yeah, it's 0 everywhere, so. And, right, so. And then we can do this dot movement person is equal distance this one divided by distance. If this dot movement percent is equal to 1, this is the position, again, this is the next position, this is the 1% equals 0, right? Something like this should work. Now we just need to make the faster stuff. Yeah, basically this is 1 or 0, right? And if one of this is 0, that means we are not diagonal. And here we really want to do this, right? Blocky.map. This dot position. We want to do something, right? Because we want to be slower on the tiles that are harder, right? So this is a good way to do it. That means we are blocked if we are on a tile that the path to cost is 0, but we are not supposed to be on a tile, the 0 path cost, right? But maybe we'll have some bugs and some of our character will be blocked, but yeah. And what we could start doing is prepare the tileable stats for tileable property for a star. And it's not really complicated, we just need to add some basic property. We'll need a public cost, public dot hash cost, right? What else? Well, hash cost, and this will just be because this is the hash cost, right? We need the parent also. That's kind of okay. Let's do this. Well, actually, we just need the parent position, right? So, this parent position. And that's it, right? The penalty is and actually we should do this in. We should add a function called reset private or public. Right, follow this, right? And so the equals 0. This the hash cost equals 0. Yeah. Thing is, parent position can be now. Yeah, we can just do this dot reset. So yeah, now we just need to make a Pathfinder class. And so for the Pathfinder, I'm just looking at an old algorithm on Wikipedia, but I also have an implementation I made a long time ago. Like for the procedural generation, Sebastian Lag has a super cool tutorial about this. He even explained how to implement threading and stuff like this, optimization, threading. So that's really cool if you want to check this out. Let's do in characters, let's add a folder called AI, right? And let's add a pathfinding. So this pathfinder. So we'll need a class, obviously. This could be static. Yeah. And it would be cool to have a struct for the result, right? Called a path result or something like this, right? And we are going to use Unity Engine. Yep. And also collection. And so we need the result, right? And we need to know if this was a success or if there is no path. And let's call this path. Right, so this will be our result object, and we'll do static is returning the path result, right? So get path. We need a reference to our map, obviously, but we have Loki for this, so we don't. So just need the start position and the goal position or end position or whatever you want. So yeah, we'll have a tile about 5.4. Tile property, right? Start, start property and we get map and obviously. Yeah. And we need to say that the start dot parent position equal start dot position. Right? It's kind of annoying because it's the name. So let's do start position. Position. I don't like this for the parent actually, but I will do this later. We also need a result. We need a bool, success, like false, and well, we don't need this right now. We just return just a pass result, right? Because I don't know this because right. So we need to start to work on this. But first we need to check that the start is not blocked, right? So if start the block path, right? And node, also the node, right? Because if one of them is false, that means we don't have a path, right? So yeah. We also need a fast priority queue. Normally I use C# library called priority queue, I guess. I don't know if I can but basically we need an open set, and this will be a priority queue. Priority queue, alright. Priority queue and the class set. We could the list of set here of Taylor property, right? The set, right? So we'll think about if we use this or if we make our own priority queue. Because everything we have no libs for now, right? Well, except the Unity ones. But yeah, that's quite obvious. And TextMesh Pro, actually. But every line of our code is, except for that, every line is open source. And so maybe we'll try to implement this ourselves. Or if I'm lazy, I'll just use the library. Which is that. Yeah, we'll continue later. So yeah, I did add the priority queue repository in assets. It's Blue Raja / high speed priority queue for C#. If you're interested, I will link the repository in the description. So now that we have this, we can continue our implementation faster. So we use the first priority queue of type property, right? Let's call this open set, right? And well, size of the queue. For now, we'll do some random stuff like this. Yeah, I need to change type property. Forgot about. So where is it? World. Here we need to use priority queue, and we need so now that we have our open set, we need to add some stuff into it. The store node actually open set that add start with start that cost, right? That's a priority. And then where we have not it set, so there's the type property current equal open set.vq. Let's check if we win. So if current equal end, we can do success equal true and break out of this, right? We need to add to the closed set the current node. Right, and then we need to reach on all. So I did this last time in the connect. So let's do how do I do that? C'est direction plus direction utils, right? Direction utils that direct. Right. And so if neighbor is null, right, or is neighbor that block path, or closed set that contains neighbor, we get into the next step. We need to calculate the cost for the neighbor. So, neighbor movement cost or neighbor cost. Current G cost plus. We need the distance actually. Same shit like we should do a method for this, right? In helpers, right? So I have some general helper. I'll call this utils. So yeah, so let's add a class, right? So here we can just in Pathfinder, we can do shit. I think this is going between current position and neighbor position. Neighbor can be nil, right? Neighbor task cost. Okay. Yeah, actually, this need to be. I don't like a function here, so this needs to be a type property, right? And call this parent, and that let's do this parent name. Right. In Pathfinder, let's do parent and start, right? What is the problem here? We use that. Oh, that's not right. Oh yeah. So if that contains number, what? Let me check what my last implementation, but no, it's not correct. This is a neighbor to the right. So if success, we need to make the so let's do a list for some GTC, right? So we just need to start from the end, right? And we try to come back to start using the parent, right? And each time we add the node to the path. Right. Do parent, run the parent, and then we do something like this. And this should work. Maybe we want basically a static class like Pathfinder manager with a queue of the path and this trading if it's slow, but for now, yeah, for now I think this is going to be fine, right? So in character movement, we just need to here we just need to set the destination, right? So we'll do pass result. Let's call this pass result, right? Pathfinder dot find dot get path. So our position is our position and test, right? If pass result dot success. Well, actually, it's not successful. We'll return for now and do nothing. But for example, when we have task and sheet, it would be to the fail condition, right? So here we need to this the pass, again new q vector to int. And this that destination next. And this should work. I'm not crazy, right? And to see if this is working is quite simple actually. We could do we can make our chicken move. So to do this, we just need to do where is our chicken? Oh, it's in base character, right? But let's do in update. Let's do this that movement that move new vector to int on the range between 15 and 35, right? To be sure it's on the map, right? Move vector. Oh, it's a private subscript. Yeah, this Greek. And we also need to register the update function. So lucky.tick to add this update, right? Yeah, this should work because we don't set the destination if we already have a destination, so it's okay that we try every frame. No? Yeah, this should work. Oh, we need to update the visual position in the file. So instead of doing this shit here, we need we do this, that movement, that visual position, right? And, yeah, I think this should work, right? Right, that's right. Not moving and it's fucking slow. Oh yeah, it's not. I know actually why it's not moving because every fucking thing in our map is not workable. So in defs. Scalable dev. Everything is not workable, right? So let's set everything to 1 for now, and let's force like the water and mountain to 0, right? And to do this, we just need to do path equal 2 for the water, and block path for the works, right? Actually, this does not block path, but it does, right? Still is not moving. That's interesting. But I don't have any errors. Cannot find. Let's draw the pathfinding grid, right? This debugger, visitors. So, yeah. Let's copy draw fertility. This draw start, right? And instead of fertility, we pass cost, right? Manager. Well, yeah, we need to change some stuff. So, but we need to draw false. If this then draw master, then draw master, and we need to change some stuff like shit. In tail property, basically we need to say that and when this is true, and we can do the same shit for plant, right? Actually, we don't want to do this for yeah, so work, I guess. Let's check our def with it. The path is false by them, right? And let's check I didn't. If we don't have block path, right? It's still not moving. So working. The path is blocked only on the water and the tile. I don't know where is that. Let's right. Let's not use this for now. Let's go to we need to explode. So why is this not working? Well, we need to debug some stuff, right? So let's debug distance. No, it's a percent. let's watch if this changed. This is there already. Yeah, so it's changing. Good to 1. So this is not the issue. Good to 1. So let's check. We have a pass here. So we have a pass. Well, let's draw the path. Right, that's debugging, right? So, how do we draw the path? Yeah, we can do something shitty. Yeah, we can do it. So, in debug random, right? Let's call this public static void draw current path character movement, right? Yeah, this is going to be, but we'll see. So, if movement that destination movement position gizmo that color that red. Let's convert the path to an array. Yeah. This is private. So the let's do for int equals 0, I pass the ends, I plus plus. Slash. Do something shitty like this. So gizmo and our line to so the position. And we always need to add this in the center, so okay. So this becomes e minus 1 should do. Why not? So let's check game manager. Another boolean. I'll pass. I get pass. If the control pass. And use the characters. Debug render. One pass. Character. Movement, right? Yeah. Going to work. Yeah, it's actually working. That's kind of funny. I did not expect this to work. So yeah, it's working. So why is this fucking chicken is not moving right now? Oh, I know why actually. I know why. I'm not sure, but I think yeah, because I do return here. Yeah. Don't need right. It's if this is the position, right? This makes more sense. Oh, moving really slow, but he's moving. So yeah, just needed to make him move faster. He's right. He's really slow. And it's not the FPS, right? We are 100 more FPS. So the speed is let's do something like this. Another queue was called on a node from another queue. Oh, what? No, it was. Let's use a simple priority queue for now, and let's use a simple. Just a simple one more. This. Don't need to size them. Don't need. We don't need this, right? This will be slower, but I don't care for now. I'll read the doc of the lib later. So why is he walking like a... I know why he's slow, but shouldn't be that slow. Right? Good. It's fine. The draw is update, right? Real update for the draw. Right. We do this in date, so so here I had a bug with OBS and I was not recording the Slim text window anymore. And I'm sorry about this, but I didn't make a lot of change. I fixed the bug in the distance in tiers, calculating the real distance because we use it in the Pathfinder. But every modif I made you can find on GitHub. Right? I have the link in the video description. So yeah, I'm sorry, I changed my sense settings in OBS to not have this bug again. But for now, if you really want to follow the tutorial exactly as I'm doing it, you should check the repository. Else, just let your inspiration do it for you, right? Try to fix the bugs yourself. Yeah, hope you enjoyed this video anyway. Sorry for that. You draw the star grid. Yeah. And see, it's kind of reddish on the grass, right? Because we are slower on grass, so they will try to, if they have, if it's faster, they will try to avoid the grass, the maximum, right? But not that much that they make a stupid decision for pathing, right? And yeah, but yeah, so yeah, now we have moving chicken. The next step is II for the chicken, right? We want them to eat grass and sleep and reproduce. Maybe. I'm not even sure. We want them to reproduce. Because maybe we want just a spawner and but yeah, this is going fine. It's kind of lagging because I accelerate the tick system, so everything is ticking often. I mean, we recalculate the matrix often, but still it's quite good, right, for the map we have. And it's in the editor, and it's a really, really big map. And the thing is, we still calculate we still draw the chicken here, right? We are still drawing the chicken, right? But we shouldn't, because that's quite right. We should not even calculate the movement, right? Well, actually, we should calculate the movement, but we should not draw them. Yeah. And we could also instance the chicken, right? And draw them like we draw the tree. So there is a lot of optimization we can do. It's starting to lag, but for now it's quite fine. So you see now then can go on the tree, right? Everything is dying in our map right now, but because the plant does not produce, right? Right, that's normal. That's supposed to happen. Yeah, so this is a bug, but yeah, I have still some bugs, but yeah. And yeah, we could do something like that the plants, right, block stackable. At least the tree, right? And also that the stackable blocks the stackable, right? Because we are not supposed to have two stackable at the same place. Alright, it's kind of useless, but still, it's logic, right? And the plant block plant, right? Same shit here. Right. But this is not mandatory. We don't need to do this because we don't try to add this, but and the mountain should block the stackable. And support roofs, right? And block building also, and block plant, right? And now if we take this into account in our generator, shit, in map, I need to make a file for this. Right here, which we are able to say if this position that block stackable equal false, right? Return only if it's false, right? And for the plant, right? Yeah, some shit like this, right? And if we do this, we shouldn't have stackable on trees, right? Yeah, there's no stackables on it. And actually, the stackable are supposed to be behind the tree, so this is an easy fix. Right? We can just do this. That means we will have grass over a stackable, and that's kind of annoying. That's why I hesitate to make two layers for this. Right, one for the lower plants and one for the... maybe we can't have a stackable when we have a grass, right? We need to cut the grass before adding the stackable. Yeah, we could also say that, right? That's just game design options, right? To know if we are lazy or not. But for now, I'm feeling lazy, so I will do stackable equal true. And we shouldn't have any stackable on the grass, right? Right, and I could check that the chicken are not in the tree, so they can move too, right? Yeah. So now it's starting to look more like a real map because we have rules for spawning stuff, right? We can have this when we are supposed to remove the grass before doing stuff. We are supposed to, right? We can't have a chicken going on a tree because the path is blocked, right? And if we draw the star grid, right? Yeah, I don't know if you can see that the grass are like reddish compared to the non-grass, but in the video, but it is but it's a really small difference, right? So it's kind of hard to see, but yeah, I don't see it in it. Yeah, I see it now, but yeah, I don't know if it's visible on the recording with OBS. So obviously when we draw all the gizmo, it's quite slow, right? But yeah, if we don't, it's faster, right? And yeah, we need to improve a lot of stuff still. We need to make the plant serious. We need to, and we need to make a real intelligence for the chickens because now they are quite stupid. But yeah, reproduction seems fun actually. So maybe we'll do reproduction because because we can modify the color of the chickens, right? If we draw them in black and white, like the trees. Because I don't know if you remember, but when we draw the trees, or the mountain actually, but the tree is a better example. Everything is black and white, right? And we have some option in our graphic data to color this, or to remove the leaves, right? For example, let's say it's autumn in our game, right? That's not the color I wanted, but it's kind of a style, right? So yeah, we can change the color easily, that's my point, right? So imagine we have multiple colors for the chicken, right? What we could do is say, like, it's me or the chicken are faster when I change the color? I'm going crazy. But yeah, we could have some chicken, and when they reproduce, we learn the color of the two chicken reproducing, and we have a new generation of colored chickens, or some stuff, or some cool stuff like this kind of a genetic algorithm, but just for the color, right? And then, well, and then it become really a genetic algorithm because if the player only chase the red chickens, they are going to disappear and have only black chicken, right? And that's kind of fun in a game like this because it creates gameplay, right? So yeah. So we need to think about this stuff, but I don't think it's a priority for our game. I'm kind of want to have people on the map and build stuff, and yeah. But yeah, hope you enjoyed. It was a cool episode and quite long, but cool. So yeah, bye bye.